In this video, we'll explore some special ways to apply regular expressions in Python to solve real-world problems. Through our examples, you'll see how features like word boundaries and look-ahead assertions can help achieve more precise matches. We'll also introduce a simple yet effective technique for generating consistent match strings, which is particularly useful in tasks like product or inventory management. Word boundaries are defined with /b. It can be very handy when you read regular expression patterns from an external source, for instance from user input or from a database. Let's use word boundaries to match a string that contains iPhone 10, but not iPhone XS, as shown in this example. Note that we need to put the regular expression in a raw string. Otherwise, you would need to use two slashes to indicate the word boundary. What if we only want to match iPhone 14, but not iPhone 14 Pro or iPhone 14 Plus? We cannot just use word boundaries because they will match all three strings. In this case, we can use the negative look-ahead assertion syntax, which matches the expression A only if it is not followed by B, indicated by the question mark and exclamation mark combination. Since we require that iPhone 14 cannot be followed by Pro or Plus, only the first one can match. Let's study another more complex use case of look-ahead assertion, which is positive this time, meaning the expression A is matched only if it is followed by B, indicated by the question mark and equal sign combination. We will write a regular expression that checks if a string contains both alphabets and numbers and only alphabets and numbers, which would look pretty complex at first sight. Let's break it down. It should be noted that two positive look-ahead assumptions are used here. The first one requires that an alphabet must follow the start of a line, and the second one requires that a digit must follow the start of a line. The order of the assumptions does not matter. The third part specifies that only alphanumeric characters are allowed in the string. Let's test the regular expression with some examples. Note that the match function is used here rather than the search function, because we want to apply the pattern at the start of the string rather than anywhere in the string. What if we don't want to match a whole string, but extract all the substrings that match such a pattern? In this case, we need to use the findAll function together with the word boundaries as introduced previously. Finally, let's use regular expressions to match ASCII and Unicode characters, respectively. Actually, in Python 3, the special character /w by default matches Unicode characters, as shown in this example. And you need to use a special flag read.ascii to match ASCII characters only. What if we only want to keep alphabets and numbers and remove all non-alphanumeric characters, including underscores? This is very commonly used to create some clean match strings for various matching purposes. Naturally, we would want to use this pattern highlighted, which matches all non-alphabets and non-digit characters. However, underscores will not be removed, as shown in this example. You may want to use some third-party library like regex to do this job. Actually, a small trick can do the same job. We just need to add the underscore to the regex pattern. Now the string is cleaned properly, with all non-alphanumeric characters removed, including underscores. In this video, we introduced some use cases of regular expressions in Python to solve practical problems. We can use word boundaries and look-ahead assumptions to achieve more accurate matching. A small trick is also introduced for how to create consistent match strings for string comparison, which is commonly used in product or inventory management. This is it for this video. Thank you for watching. If you enjoyed the video, please subscribe to my channel for more content. As a senior software developer, I'm passionate about sharing my thoughts, tutorials, and solutions to promote best practices in software development. See you in the next video.